Welcome everybody to Algebra 2. Today we've got a little introduction. When we're moving into Chapter 3, we're going to be solving quadratic functions, and one of the fastest ways to do that is by factoring. And we thought it'd be a good idea to take a couple days, revisit all of our factoring techniques, because factoring is the fastest way that will help us solve these. So a lot of this will be a review of things that you have done in Algebra 1, and maybe we'll be showing you some different methods of factoring, hopefully bringing the ideas together to help make you as efficient with this process as possible. So 3.A, solving quadratic equations by factoring, part 1. So introduction, remember that the word factor just means a piece of a multiplication problem. So the math vocabulary is that two factors multiply to make a product. So we're trying to split up the multiplication that's happening inside these functions. So second point there, to factor a quadratic, we're rewriting it as multiplying factors together. Usually with quadratics, it's two factors, but there could be more if one of those factors is a number. So the first method of factoring, of like undoing this, combining like terms and things like that, is undistributing. We call that a GCF. And what that does, that greatest common factor, is it's a nice way of splitting up something that has two terms. So we'll see some examples of that, but just remember that if I were to take like 3x times x plus 2, distributing means multiplying in, simplifying that multiplication that's happening. We're going to try and go back to this point so that we can see the two pieces of multiplication there. So for instance, that would be how we would distribute. GCF means we're working backwards from that. Okay, another method of factoring, you probably remember the term magic numbers. That's what we use here at Hananiga to describe the process of factoring a trinomial when we are undoing the FOIL method. So let's take a look at an example of foiling. Let's just do x plus 3 times x minus 7 for an example. The FOIL method says take first times first, that's x squared, then outside terms, multiply those, negative 7x. Inside terms, that's plus 3x. And then last times last, negative 21. Notice that when I did first times first, that produced this number. When I did last times last, I got that negative 21. And then inside, we have the outside and inside O and I in FOIL when we go through that method. Those are the numbers adding up to make the middle term. So you'll see that negative 7 and that positive 3, they add up to make the middle term. When we have this trinomial, it will become negative 4x in the middle, but they also multiply to make the last term. So that negative 7 and that positive 3 are what we refer to as the magic numbers, the outside and inside of FOIL. All right, some important terms that you may see showing up here. Solving by factoring is, once we have an equation set equal to 0, if it's quadratic, then we will factor it if it's possible, and use what we call the zero product property to solve. And the zero product property, this is why we have everything set equal to 0 when we factor. That's our first move. It's if I have two things multiplying together, two factors creating a 0, then either of the factors being 0 produce that zero product that we want. So it just makes sense. It kind of gives some meaning behind the process that we do. And then lastly, a difference of perfect squares. If we have a quadratic function that's made up of two terms of the form ax squared minus b, so there's no x term in the middle, no regular x term, then a and b are perfect square numbers, we have a faster process for factoring those. It's something that doesn't require magic numbers, though magic numbers would work. But it's just treated as a separate pattern entirely because it's so much quicker. Let's get into our examples here. So the first one, finding the GCF of all terms, what can I undistribute? So it looks like at the coefficients 2 and 10, I can divide a 2 out of both of those. And x squared and x, I can divide an x out of both of those. So if I divide 2x out of 2x squared, I'll just be left with 1x. And if I divide 2x out of 10x, I'll be left with plus 5. Nice thing is that this backwards distribution, undistributing, it's very easy to check your work. Just distribute it back in and see if it leads you back to where you came from. So that is our answer for the first one. For letter B, coefficients-wise, I cannot divide something out of 1 and 5. They don't share a factor that I could divide out. but I can divide an x out of each of those terms. So if I divide that x to move it out front, undistribute it, I'll be left with 1x minus 5. Again, what can we divide out of both terms? Look at the coefficients, then look at your variables and powers. Example 2, here's our practice with the magic numbers work. And these are trinomials that have an a value, a number out in front, a leading coefficient of 1. You can see that we don't see anything like 5x squared to start off a problem. It's just a regular x squared. So here's what we do. We look and see what multiplies to be 6, right? That's going to be our last times last in the factors, and also adds up to be this positive 7. So after a little bit of thinking, 6 and 1. If I multiply those together, I get 6. If I add them up, I get 7. So my factors are going to start off with x times x for my first times first. That'll make x squared in the trinomial if I were to FOIL it back together. And then those magic numbers, positive 6 and positive 1, if I do last times last, that combines to make that 6 at the end. And we should have a lot of practice under our belts with foiling, so it shouldn't be too much work on our part to envision the foiling process to check our work as we go along. For the second one, okay, what multiplies to be positive 8 and adds up to negative 6? My magic numbers are negative 4 and negative 2. Just do a quick check. Do they multiply to make positive 8? Yes. Do they add up to make negative 6? Yes, they do. So I can jump right to my factors. The first part will be the variable term. In this case, they're just y's because they make a 1y squared when I do first times first. And then I throw my magic numbers in there as well, negative 4 and negative 2. Quick check. Last times last makes positive 8. Inside and outside, O and I and FOIL make negative 4y, negative 2y. Hey, that adds up like it should. It's factored. You'll notice I'm not doing a lot of writing. That means that we've got the process down. That's why factoring is so fast. There's not a lot of writing for us to do. Example C, what multiplies to be negative 12 and adds up to negative 4? That's a negative 6 and a positive 2. So let's set up our factors. Out front, I've got to have x times x for my first times first. Then magic numbers, minus 6 plus 2. Quick check as I run through FOIL. Yeah, that'll make negative 4x in the middle. And last times last gives me negative 12. It works. And finally, what multiplies to be negative 27 adds up to positive 6. That's a positive 9 and a negative 3. So let's set up our factors. First times first has to make z squared, so those must just be z. And then positive 9, negative 3, complete those factors. That's what the magic numbers are for. We've got our answer. All right, our third example, the difference of perfect squares. So notice that this is a 1x squared and a 9, and it's subtraction in the middle, difference. Okay, that's where we get that terminology there. So 1x squared, 1 is a perfect square number. 9 is 3 squared. It's a perfect square number. So we may want to make a list of those perfect square numbers. Anything that can be arrived at by taking a number times itself is a perfect square number. So we've got that case here. I can jump right to my factors, and it is still kind of foiling together. So my first times first does make, in this case, 1x squared, so it's 1x times 1x. My last times last has to make 9. And since it was a perfect square number and everything in the middle canceled out, I need a positive 3 and a negative 3 combining together to cancel out the O and I in FOIL. This is our answer. It's a very fast pattern, and one that after you've done like 4 or 5 problems, I think you just have this one down, as long as we know how to spot it. So letter B, I've got something x squared, a difference minus another something, and hey, both of those somethings are perfect square numbers, 25 and 49. So I can go right to my factors, and let's think FOIL. First times first doesn't just make x squared, it makes 25x squared. That had to be 5x times 5x. Again, those have to match because I'm going to need them to cancel out in the middle. To make 49, that's 7 times 7. Again, 1 positive, 1 negative. If I quickly check with FOIL, is that middle going to cancel out? Am I going to get 0 for a b term in the middle? Yeah, I'll get positive 35x and negative 35x, so it checks out. The final task is solving by factoring, and the biggest mistake I see students make here is they don't set it equal to 0 first. To solve by factoring relies on us using the zero product property. So if we're not set equal to 0, then our zero product property doesn't have the 0 that it needs to run. So for letter A, we're already set equal to 0. So let's set our factors equal to 0. I know that since it has a leading coefficient 1, it's just going to be 1x times 1x to lead off those factors. What multiplies to be a positive 6 yet adds up to be a positive 5? I know those magic numbers are positive 2 and positive 3. Now, we're not done. We've factored it. We've done the tough part. Now we just need to gather the solutions out of those factors. So out of the first factor, if that were to equal 0, then x would be negative 2. Essentially, we can switch the sign on that magic number is the short way of doing this. But again, to see the zero product property at work, what would make that second factor 0 if x were equaling negative 3? So we get those two solutions for this problem. When it says solve, I better be saying x equals at the end of the problem. For letter B, this one is not set equal to 0, so before I try to factor, let's subtract 28 from both sides. Make sure it's in standard form, meaning x squared, then x, then our constant set equal to 0. And now we can go through our factoring. Those factors will multiply together to make 0, zero product. Again, leading coefficient 1, that's going to be true in all of our trinomials today. And we've got x times x leading off those factors to make that 1x squared. What multiplies to be negative 28 and adds up to be negative 3? That's negative 7 and positive 4. And I might quickly run through FOIL to make sure I do get back to that trinomial in the step above. Then the solutions, what would zero out this first factor if x equaled positive 7? What would zero out this second factor if x were to equal negative 4? Then they would combine together to make 0. There's our solution. For letter C, here you'll notice I don't have a full trinomial. It's already set equal to 0, so this is a case where there's only two terms. Can I take a GCF out of that? And sure enough, I can undistribute an x from both of those terms, so I have it all factored out. The first factor, x, could zero out. The second factor, 3x minus 1, could also zero out to give me that zero product. Add 1 and divide by 3, x equals 1/3. Those are my two solutions. Realize that when you use the GCF method, x equals 0 will be a solution as long as there is a loose x out front. So if we can see factors out there even if they're not part of parentheses as well. Remember, they're still part of that multiplication. And finally, letter D. I see two terms, so I'm not going to use magic numbers for this one. I do not see a GCF that I can take out. So what about difference of perfect squares? 4 is a perfect square number, as is 9, and we're subtracting in the middle. Let's factor this as a difference of squares. First times first has to make 4x squared, and they have to match, so that's 2x times itself. Last times last has to make negative 9, and they have to match, so that's plus 3 in the first factor, minus 3 in the second. And then we can go about solving. That first factor could equal 0. Subtract 3 and divide by 2, x equals negative 3/2. Or that second factor could zero out to give us our zero product. 2x minus 3 could equal 0. Add 3 and divide by 2, x equals positive 3/2. All right, there you have it. Again, hopefully this was a review. I apologize if this video went kind of quickly through those. The main thing I can stress is get the practice. This is such a procedural thing. You will amaze yourself once you get through like maybe 10 problems worth of this. You really start knowing what to look for and you can pick up the pace quite a bit. All right, your assignment that goes along with this is a worksheet. You can find that on the website, or you've probably already gotten it handed out in class. So hope you've enjoyed this video. Hopefully it's a nice refresher on something that we've learned in Algebra 1, and good luck with this topic.